Let's keep going with this. The next one on our list is waste to energy, which is ranked number 68 with 1.1 gigatons of CO2 expected to be reduced by 2050. The net cost over these 30 years is $36 billion, and net savings are expected to be $19.8 billion. And we always see these kinds of images where there are processes being used to convert trash. Some refer to it as trash to cash and recovering resources and so on, but there is tremendous controversy from environmental people saying that this may in fact negatively affect efforts to recycle and to actually reduce total waste, because if people think somehow waste is being converted to energy, they may feel like there is no need to worry about generating waste. So the amount of waste generated keeps going up, and we end up with these sorts of landfill sites which are an eyesore, unhealthy, stinky, and leave behind tremendous amount of plastic and so on that will never degrade and can be found several feet under the land, underground as well. This is just something I took from EcoMaine, where it says waste to energy. So it's a tipping hall, there is a trash storage bunker, there are several processes with which the trash is converted to byproducts like ash, and then various water vapor and clean flue gases and energy and so on and so forth. So there is nitrogen oxide removal here in the first stage, mercury and dioxin removal, so they are toxic substance that you don't want to get anywhere near. Acid gas removal system, particulate removal system, so you don't want too much particulate matter being put out by these processes of converting trash to energy either. And pollution control tests, so before things are put back into the landfill, such as ash or flue gases and water vapor, you want to be sure that you are not releasing much worse than what the trash would release on its own. Sweden is supposed to be a country that's actually importing trash from other countries, almost up to 1 million tons per year, I think, and has claims to a very clean way of converting that to energy, minimizing CO2 emissions, minimizing residual byproducts, and so on. So there are comparisons made which shows that Sweden is actually reducing emissions compared to landfill and other processes in its trash to energy program. The processes used for dealing with trash waste are thermal technologies, direct combustion, so mass burn, and residue derived, so fuel. Is it residue? Residue derived fuel, pyrolysis, which is a high temperature chemical reaction process, conventional gasification, and plasma arc gasification. So these are the main processes that are typically used. The arguments against these ideas of waste to energy are strong, saying that the best way is to move upstream and reduce the waste generation in the first place and head towards zero waste, instead of assuming that people can keep producing waste and then they will somehow be converted back into resources, or that they can somehow produce energy and reduce emissions significantly. So many companies are going in this direction of reducing their waste products in the first place. So the risks of waste to energy are significant, but it has some benefits. 1.1 gigatons of carbon dioxide emissions can be avoided by 2050, primarily due to reduced methane emissions from keeping waste out of landfill. So if you dump stuff into landfills, and then there is lots of anaerobic respiration happening of whatever is biodegradable. There is methane, which makes these places very stinky as well. Plus, they have lots of social issues. Poor people digging through them looking for recyclable material or other stuff that they think they can sell and make money. Considering the disadvantages, this is a bridge solution, one that will decline as preferable waste management solutions, including zero waste, composting, and recycling become more widely adopted globally. Zero waste is considered pretty much a pipe dream, but nonetheless, there it is. Island nations with limited available space may continue to use waste to energy as an alternative to landfills. They don't have enough space. New York City, for example, exports its waste to New Jersey, and there are other states which export waste as well, I think. So island nations cannot easily do that. Employing more advanced technologies such as plasma gasification to limit negative impacts, island and nations may be able to continue to use waste to energy as an alternative to landfilling. A 36 billion cost to implement, savings over 30 years could be 20 billion. Again, this is listed as a regrets solution in the book, as opposed to a lot of the no regret solutions like wind, solar, and others. Okay, just like nuclear, this is also a regrets solution.